Hello everyone, I'm Jenny, Assistant Professor from IT Department. Today lecture is soft computing. Course outcomes. Course outcome one, explain the biological neuron model and architecture of artificial neural networks. Apply precision and multi-layer feed-forward neural network models and classification problems. Analyze learning rules, Sabin learning data rule and back propagation algorithm. Course outcome four, implement neural network training and testing procedure and evaluate network performance. Course outcome 5, apply neural networks to real-world applications such as pattern recognition, prediction, and data classification. Syllabus first unit covered to introduction to soft computing and fuzzy logic, and unit 2 neural network. Unit 3 genetic algorithms. Unit 4 neurofuzzy modeling. Unit 5 application of soft computing. So now unit 2 continuation. Unit 2 is neural network about. So the continuation, next one, LMS learning. So LMS, what is LMS? LMS means least means square learning. Learning. It's a learning rule used to train neural networks, minimize the error between target output of T, actual output of O. The neuron first calculate the raw output O equal to element of wi xi plus theta. So wi is equal to weight and xi equal to input, theta is bias and o equal to output. Then the LMS error formula is d equal to 1 by 2 element of tp minus op the whole square. This is called the mean squared error. So where TP is target output for pattern P, OP is actual output. The score max error always positive. 1 by 2 is used to simplify differentiation. Whole is to minimize the error. So given T1 equal to 1 and O1 equal to 0.8, T2 equal to 0, O2 equal to 0.5, then D equal to 0.5. Now O2 equal to 0.5. Now calculate D equal to 0.5 into 1 minus 0. The whole square plus 0 minus 0.5 the whole square. Simplify the 0.5. 1 minus 0.8 is 0.2 the whole square plus 0 minus 0.5 is 0 minus 0.5 the whole square. So 0.5, 0.4 plus 0.5. So we get 0.5 into 0.29. Totally we get total error is 0.15. So the graph shows x-axis weight and y-axis shows the error. The curve shows how error changes with weight. So W of old equal to current weight, W of new equal to updated weight, C equal to learning rate. The algorithm moves the weight with the downhill on the curve toward minimum error. This process is called gradient descent. So to update weight using weight new equal to weight old minus n. Then n equal to learning rate and slope gradient. Next is LMS gradient descent. So the LMS gradient descent, how weights are updated to minimize error. So LMS least mean square, we want to minimize the error between target output of T, actual output of O. To minimize error, we move weights in the direction that reduces error fastest. Then error function. Error function, this is means squared error. Make a E as small as possible. Then change in weight. So landing rate, slope of error. So it's inside the negative sign because we move opposite to slope to reduce error. Since error depends on output and output depends on weight, this is called chain rule. From the error formula, the derivative with respect to error divided by S of Vk equal to error S of Oj into S of J Wk. So totally, finally, triangle of Vk equal to C of Tg minus 0. Then Derivative the activation function, we got input function. So combining everything, we got tj minus c2. So we cannot remove the sum since we taking the partial derivative, right, oj. Then activation function. Uh, we need to an activation function for LMS delta rule, and the old prescription function doesn't work. So first, to apply LMS landing delta rule, we need, because LMS uses a gradient descent, and gradient descent requires taking derivatives. Update data rule, weight update rule, that is data rule, where landing rate, uh, WK equal to landing rate, then input, target output, actual output, derivating activation function. So we need to record. Then old activation suddenly jumps from 0 to 1. So not smooth, no, not differentiable. Now activation function sigma. So sigmoid curve graph representation, smooth shaped curve, output between 0 and 1, differentiable everything. Then important of precision landing rule is user step function, no derivative, limited capability. So LMS is use differentiable activation like a sigmoid, and allows gradient descent and can handle more complex problem. Then LMS with limited threshold. So LMS is the limited threshold is the new sigmoid function that is differentiable. We can apply the data to rule toward learning. Perception method first output 0 to 1, while LMS uses the net output. So guaranteed descent method to may oscillate and not converge. Many converge to wrong answer. Will converge at some minimum even if the classes are not linearly separable, unlike the earlier training method. Next one, back propagation network. So back propagation network is one of the most important algorithms in a neural network. Then what is before going to see this, what is back propagation? Back propagation is a training algorithm for multi-layer neural network. It was introduced by 1970. It allows neural network to learn complex patterns, solve non-linear problems. So we need to back propagation means single layer perception can solve only linearly separable problems. Back propagation uses a multi-layer networks can solve complex classification problem. Um, in the structure of the back propagation network is in the figure. Yeah, we have input layer, hidden layer, and output layer. Input layer, we have L1, L2, I1, I2, I3. These are input features. Then hidden layer, H1, H2. This is weighted input, supplies activation function, weights between input and hidden layer are. Output layer, O1, O2, final prediction weights between hidden and output layer. This hidden layer h of x equal to 1 divided by 1 plus e sigma I wi x comma I. This of equation is for a sigmoid function. Then why sigmoid function is it's a smooth on differentiable record for gradient descent. Then how propagation back propagation works means forward pass. The forward pass, that is input to hidden to output. Compute output using weight and activation function. So calculation of the error equal to target minus output. Backward pass means error is propagated backward. Compute gradients using chain rule. Update weights W equal to W minus infinity, that is minimize total error. Then propagation network, back propagation network, important features in multi-layer network, fully connected, feed forward, without loops. We can uses gradient and uses differentiable activation. Then important for this back propagation is the solved XOR problem. Revived neural network research forms the foundation of deep learning. Then back propagation learning procedure. Random assign weights between 0, comma 1. Present inputs from training data propagate to outputs. Compute inputs who adjust weights according to the delta rule back propagating errors. The weight will be merged closer to the network lines to give the desired output. Stop until no errors or no pulses completed. Then backprop modifying weights. We have completed the how weights are. Back modifying weight means how weights are modified in back propagation. That actual update formula is output in hidden layers. Uh, we are updating weight using delta W equal to Z into error term into input into derivative. So Z equal to landing rate, T means target, O equal to output, F equal to sigmoid activation. So formula, the first line formula shows activation is sigmoid, F of x equal to 1 by 1 plus E, the minus x. It's derivated by f1 of x equal to fx of 1 minus f of x. So we replace the derivative, the final, the output unit, so if sum of O equal to K, the output units. So then weight update output layer, since f of sum equal to 0 K, that is weighting change, learning rate, hidden neuron output, output error, sigma derivative. Then weight update for the hidden line, the third line, hidden line skipping some max. This is final formula that is. Then it means learning rate sigma derivative of hidden neuron x input sum of output errors weighted by WJK. Then 1 high minus HO. This diagram, W of ij equal to weight from input to hidden, WJK equal to weight from input to output. Then output layer Sk equal to Tk minus Ok, Ok into 1 minus Ok. Hidden layer equal to H of G equal to 1 minus H of C. Then weight update, triangle W equal to C into input of infinity. Then finally, in back propagation output layer, weights are updated using the direct error term T minus O. Hidden layers weights are updated using the error propagated background from the output layer. The sigma derivative is in the both cases. This allows network to minimize error in the gradient. Then backprop. Backprop very powerful, can learn any function given enough hidden units. With enough hidden units, we can generate any function. Some problem of generalization is memorization. With the too much many units, we will tend to memorize the input and generate well. Some schemes to exist to the neural network. Networks can be extremely slow to run, may also fail in the local minimum. Despite the concept, very powerful algorithm that has been successfully deployed. Then a back drop demo.